Pop quiz, what is the most important device in your bathroom? Well, it's the GFCI. It's the GFCI outlet that is in your bathroom because here's the deal, it prevents you from being shocked. And I don't know about you, but the last thing that I want to have happen is get shocked while I'm either flat ironing or blow drying my daughter's hair in the morning before school. So anyhow, today we're going to show you how to install a GFCI outlet. I'm going to have my buddy Bill White from Livewire Service Group show you how to do this. He's a licensed electrician here in Pittsburgh. He's got a ton of awesome tips for you. We're going to walk you through that step by step. So let's get to it, and in the end, we're going to have a huge surprise for you. So stay tuned. Today we're going to show you how to install Leviton's SmartLock Pro Self-Testing GFCI. And the reason why is it meets the new requirements by Underwriters Laboratories Standard 943, which requires all new GFCIs to be self-monitoring. So why did the UL people do this? Well, you should be testing your GFCI every 30 days. And by test, I mean you hit the test and then you hit the reset button. But nobody does that, and they realize this is a big problem. So that's why Leviton came out with the self-testing GFCI, and you should totally install this in your bathroom, kitchen, or garage if you're doing a remodeling project. That way you'll stay within the new requirements. In this video, Bill's going to show you how to wire a GFCI like he would do it. And I think this is critical. Like we've said in other videos, the GFCI is perhaps the most important device in your bathroom, or even in the kitchen if you're redoing a kitchen. But in this case, we're talking about bathroom remodeling.
Before beginning any electrical project, turn the power off at the circuit breaker or fuse box.
Now, when you strip a wire, I do this all the time. So I use my linesman's. This is a set of linesman's. This is the electrician's most important tool. This is used to actually twist and prep the circuit and also strip the jackets off. Now for me, as a professional and used to doing this, I can just grab the wire and pull on it and get the jacket off nice and clean. All right, so whenever you're stripping your wire, part of the reason why I use my linesman's is the distance, the thickness of this linesman's is the distance that you should be stripping your wire. This stands true for pretty much most electrical connections, not just your outlets and your switches, but also if you're working in a panel or anything else. This is your standard distance of stripping, which is roughly 1/2 inch to 3/4 inch. Now the reason that you want to strip it to that length is any standard connection for electrical is always going to be about 1/2 inch to 3/4 inch. This will make sure that the copper gets clamped into the clamp properly, but the plastic doesn't get behind there. You never want this plastic from the jacket here to get behind your clamp. That can cause a bad connection to your outlet, and bad connections cause heat, and heat causes electrical malfunctions. So once we get this in here, you're going to want to use a flathead screwdriver. This screw must be very tight, not terrible tight. Terrible tight meaning that you can actually ruin the screw, but tight enough that this wire will not pull out. And a good way to check that is once you get it really tight, you're going to want to twist the outlet back and forth. Now if the wire twists with the outlet, you're tight enough. If the wire twists separately from the outlet, meaning that like if this is just a little bit loose and this thing spins around but it doesn't twist the wire, that's not tight enough. That right there will generate heat. This is a GFCI outlet. Whenever you take this thing out of the package, you're going to have yellow tape on 2 of the terminals, and the other 2 terminals are going to be exposed. The screws will be drawn out, ready to take the new wires. The terminals that are behind the taped off section here, this is called the load side of this outlet. Most standard outlets, everything's connected together, but this, you bring your power supply into these 2 terminals. Now always remember, your black wire goes to the gold screw, white wire goes to the silver screw. You put your black wire in with the gold screw. Now this is a pressure plate. So this wire is not meant to be wrapped around the screw, but to go behind the pressure plate. Pressure plate has a bunch of teeth in it, and it grabs onto the wire. Now the reason we're going to connect this to the line side is because this is the side, these are the terminals that power the outlet. These 2 terminals are the load terminals. That is GFI protecting another outlet down the line. So you would bring your power supply into here, and your other outlets would get connected to here. that GFI protects other outlets. So like I said, flathead screwdriver for these. Now this is the kind of screw that does have options. It can take a Phillips head, a square tip, and a flathead. I always recommend using the flathead whenever you're doing these connections so that you can get them extremely tight. Now this one, see that outlet? Very, very tight. Those wires are twisting right with the outlet. Same thing with the ground. GFCI outlets are all designed with pressure plate type connections. That means that you can just shove the wire right in there, tighten the screw down. You're not going to get a better connection than that.
One of the cool things about the SmartLock Pro Self-Testing GFCI outlet is that it has a very, very slim profile. What do I mean by that? This is the profile of it, okay? And if you have an older box in your bathroom, kitchen, or garage, an older electrical box, this should be able to fit into it. Some of the other GFCIs are wider and not as slim, and when you go to push them into the electrical boxes, it crunches all the wires in there. It's not a good thing, it's not safe. So a slim profile is what you want.
We already have our GFI wired up. There's only one other detail. Whenever you go to tuck your wires, now the wire is coming down into the box this direction, so what I do is I take my finger, I push it on the two wires, I push all the way to the bottom corner of the box. Now one thing I should have mentioned is the length of your wires. The length of your wires coming out of your box should always be 6 inches from the back side of the box. You need to have 6 inches of wire. The reason why is, for one, so you can work on your device, and two, your ability to tuck these wires. If it's 6 inches long, the box is 3 inches tall. This gives us the ability to have 2 loops before going to the device. So whenever we tuck the wire, we push on this all the way to the bottom corner. That'll consume 3 inches of the wire. And then I'm going to push on this side. This will go all the way to the top corner. That's the other 3 inches. The remaining distance I have left is, I always go longer than 6 inches. The code only requires 6, but I always go for 8 because it actually does make it just slightly easier to tuck your wires in. You get this device set up, and what I always do, I don't like to line the screws up with the holes. Sometimes they get in the way. I turn it a little bit to the side and I push the outlet all the way in. This makes my wires bend to the position they're going to be sitting after the device is installed. It makes it a little bit easier to put the device in. At that point, you can pull it out and then get your screws lined up with the holes. And you could feel that the wires are now already set to be bent in a position like that. So this actually helps hold your device in whenever you go to install this outlet. Now you notice that I have my ground side up. Everybody these days loves to see the face, the smiley face in your wall. Well, in today's code, specifically 2014 code, this is actually a 2012 code as well, that if you have an outlet that is above 36 inches off the ground, they assume that you can have a countertop put in underneath this outlet. Now, if you can have a countertop under there, they're afraid of utensils and other metal devices falling and hitting and striking where your outlet is plugged into. So we have the ground side up, so that if anything falls, the first thing it hits is the ground and not one of the hot legs. So we always do ground side up if we're 36 inches off the floor. All right, so this box is set in place. Simply take our drill, this extra little guy here, tighten one, and we're done.
Leviton's patented reset lockout feature prevents the outlet from being reset if it does not work properly. And you know that it's working properly when you see the green LED light. If that's red, you have to replace your GFCI.
2 important things here. Number 1, if you're unsure of your work, call an electrician. Call in somebody like Bill, who's a licensed electrician and knows what they're doing. Number 2, when you do install an electrical device like the SmartLock Pro GFCI, make sure you read the directions the whole way through. Don't skip any of the steps. Well, there you have it. That's how you install a GFCI outlet, and thank you, Bill, for showing us how to do it the right way. It's always nice to have an electrician share the tips and tricks that DIYers may not be aware of, so thanks again, Bill. Now here is the surprise. We're going to be giving away 3 of these SmartLock Pro self-testing outlets to 3 random fans over on Home Repair Tutor. So click on one of these buttons, go over to Home Repair Tutor, enter the giveaway, you'll be really happy that you did, and I think that you'll enjoy these outlets for yourself, okay? All right, that's it for today. Remember, if you haven't already done so and you want do-it-yourself advice, subscribe to the YouTube channel, the Home Repair Tutor YouTube channel. We have a new video that comes out every single week, and we're gonna be doing a lot of giveaways moving forward, so don't miss out on that. Thanks for watching, take care, and I'll talk to you soon.